Okay, Bismillahirrahmanirrahim. In this video, I'm going to talk about mechanical exfoliation, the Scotch tape method, okay, which is this method that being developed by the founders of this method of graphene lah. Okay, the tape method, which is theoretically everyone in the household can do it with the Scotch tape only. Okay, with the Scotch tape only. Okay, this is the overview, and they will be the process that you can see in the figure, the figure diagram into graphic into the video, which you can replicate it at your house. Okay, you can replicate. Everyone can replicate this product. Okay, everyone can replicate the how to make the Scotch tape method. This is very easy. Okay, so mechanical exfoliation, the Scotch tape method, the mechanical exfoliation method, popularly known as Scotch tape method, holds a legendary status in material science. It was through this deceptively simple technique that graphene was first isolated in 2004 by Andrei Kim and Konstantin Novoselov, an achievement that earned them Nobel Prize in 2010. This technique may seem low tech is revolutionize the world of nanomaterials by proving that stable two-dimensional atomic crystals could exist. Okay. Overview process mechanical exfoliation is a top-down approach that involves peeling ultra thin layers from a bulk graphite source using adhesive tape. The goal is to obtain a monolayer of graphene, which consists of just one layer of carbon atoms arranged in a honeycomb lattice. This method works because of the van der Waals force between layers in graphite are relatively weak compared to the strong covalent force within each layer. As a result, repeated peeling with tape can separate individual layers. Okay, step-by-step process. Okay, step-by-step process meaning that everyone can do it at your home. Start with graphite. A piece of high purity graphite is selected as the starting material. Apply adhesive tape. The tape is pressed firmly onto the graphite and peel away. Then lifting the thin flakes with it. Repeat folding and peeling. Okay. The tape that with flakes is folded and peeled multiple times to thin the graphite to a few or even single layers. Transfer to substrate. The tape is pressed onto a silicon wafer for other substrate for upon removal. Graphene graphite layers often invisible to naked eye, high optical microscope and AFM optical contrast method or ultimate force microscopy. AFM is used to locate and verify monolayer graphene. Advantages: high quality, produce pristine, defect-free monolayers ideal for fundamental research. Uh, uh, Simple setup requires no complex equipment, only graphite, tape, and substrate. Even you can also do it at your home. Uh, Low cost for labs, highly affordable and accessible in academic setting. Preserve intrinsic properties. The graphene remains chemically unmodified. Limitation: not scalable. Use are low. The process isn't viable for mass production. Irregular flake size. Flakes vary in size and shape, often unsuitable for device fabrication. Low reproducibility. The process can be inconsistent and relies on trial and error. Okay, conclusion: while mechanical exfoliation is not practical for large scale production, it continues to be indispensable for graphene research. Its simplicity, purity, and naked make it ideal for method for exploring the fundamental properties of graphene. Okay, and as you will see in future episodes, more scalable techniques like chemical vapor deposition, graphene oxide, and reduction, and built on scientific foundation laid by this method. Okay, okay, that's all. You can find my books. Okay, you can search for my books in the website